Okay, today's topic is over parametric tangent lines. Hopefully you already know what a tangent line is. I went over it in my last video. It's a representation of the slope of a function at a point. Parametric in this sense describes a tangent line on a parametric plane, meaning a plane where any coordinate can be represented by two separate equations. So the formula for a tangent line remains the same. As rectangular, it can be modeled as y minus a equals m x minus b. Now the coordinate in reference is just, we'll call b minus ba. So the b is the x coordinate, a is the y coordinate at a certain point. However, although the formula remains the same, it is a separate process to find what m is, because m is the derivative at a certain point. But in parametric, m is a bit separate. So typically, we would write any equation, or sorry, any differentiable equation of y with respect to x as dy dx. However, with parametric, we should rewrite it as dy dt over dx dt. So as I said earlier, any curve or any function in a parametric plane can be represented by two equations, an equation for the y and an equation for the x. In order to find dy dx, you're going to want to find the derivative of the y equation over the derivative of the x equation. And you're going to, of course, want to do that at a certain point t equals like c. It doesn't matter. But that's what your m should be. That's how you find the slope at a certain point in a parametric plane. And that's important to, of course, find the parametric tangent line. I should also point out that this is only featured in Calculus BC, not AB. Okay, before we get into practice problem 1, I want to point out that although I said a parametric function can be represented as y and x, both in respect to t, this isn't necessarily true. You're going to have two different functions two different equations to describe a function, but they don't necessarily have to be y or x, and they don't even have to be in respect to t. But for the sake of this video, they are. So the first equation is, or the first question is, find the line tangent to y equals sine t and x equals t squared plus e to the power of t at t equals pi. So first thing we're going to do, we're going to want to find the coordinate at which this occurs. So first we're going to find x of pi, as that's going to be our x coordinate at this point. And that can be modeled as pi squared plus e to the power of pi. From here, we just have to find y pi, which is sine of pi, which hopefully, as you know, if you've memorized your unit circle, is equal to 0. So all we have to find out is dy dx. And I'm going to model this as dy dt over dx dt. So let's first start off by finding the derivative of y. I should also say that this occurs at t equals pi, because that is the point at which we're trying to find the derivative. So dy dt is equal to the derivative of y, which is the derivative of sine of t, which is going to be cosine of t. So we can fill it in over here. Cosine of t will be our numerator. And so we're going to find dx dt, as that's our denominator. We haven't yet solved that. So dx dt is going to be 2t plus e to the power of t, because we're just taking the derivative of x with respect to t. So our denominator is going to be 2t plus e to the power of t. Now I'm going to erase a bit over here. Hopefully I'll remember what the coordinates are, but I just need to make space for the time being. So this is x, this is y. Okay, I just need to make space. So we need to solve the derivative for at point r, t equals pi. So we can plug that in. Cosine of pi is -1 over 2 pi plus e to the power of pi. And so we have our derivative, we have our coordinate, and so there isn't any information that we still need to find in order to write our tangent line. And so we might as well write that now. I'll just give the template for, or the general formula for the tangent line, y minus a equals m x minus b. So for this question, y is going to be 0. And so we can exclude that. N is -1 over 2 pi plus e to the power of pi. And of course, we have to throw in the x minus b. B in this instance is pi squared plus e to the power of pi. However, we're going to distribute the negative sign, which I forgot to add, rather than put parentheses around the whole term. So this is our tangent line. Of course, you can simplify this further. However, you generally won't. AP doesn't really require you to simplify. Rather, your teacher may. And so if that's the case, then you should simplify. But for the sake of AP, I'm not going to. Also, I'm lazy. But this is what we have. This is our tangent line for the function represented by y equals sine t and x equals t squared plus e to the power of t at t equals pi. Okay, this is practice problem 2, and in fact, the last practice problem for today. We're told to find f of t, f of 3, if f of t can be represented as y equals 3t and x equals natural log 2t. So first, we might as well find our coordinates. X of 3, I should add, can be represented as natural log 2 times 3, as we're just plugging in 3 for t. And so we'll just say that's natural log 6. And y of 3 can be represented as 3 times 3, which just happens to be 6. So we have our coordinates. From here, we just have to find the derivative of our function, which we can say is dy dx, which is equal to dy dt over dx dt. And so we'll find dy dt, which is, of course, just the derivative of y with respect to t. And that's equal to 3. No need to throw in the point at which t should be, because t isn't in the derivative of y. So we're going to throw that in as the numerator. Now we just have to find dx dt, which is the derivative of x with respect to t, which is going to be 1 over t. Now this is because the derivative of natural log 2 over t is equal to 2 over 2t. You can see that the denominator is just the term inside natural log of 2t, and 2 is the derivative of the inside of the natural log 2t. And of course, we simplify. So our derivative is really 3t. Of course, it's actually 3 over 1 over t. However, if we simplify, we end up with 3t. And I don't believe AP will require you to simplify it in such a way, but for my sake, I'm simplifying it because it makes it a lot simpler. I mean, that's what simplifying does. So from here, we just have to find the derivative when t is equal to 3. We can use 3 in place of t, and of course, we end up with 9. So our slope at f of 3 is 9. Our x coordinate is natural log 6. Our y coordinate is 6. And so our tangent line can be represented as y minus 6 is equal to natural log x minus natural log 6. And that is the final answer for our question. If you have any suggestions for future videos, please put them in the comments below. Thank you.